Alright, calculus class students, so just want to talk about 3.4, the chain rule. So formulas that you need to recognize, so you do remember the composition functions, the phi, the ga, or f of g of x. So the way to take the derivative of the composition, it's about finding the derivative of the outer function, f prime of g of x, and then you want to take the derivative of the inner functions, which is g of x, g prime of x. And then alternate form, so let y equals f of u, and then u would be considered g of x. So that means the derivative can be written as dy over du, and then times du over dx. So that's the alternate form. Okay, so again, it's all about the derivative of the outer function first, and then times the derivative of the inner function. Okay, so we'll look at that example. And also we can use the power rule with the chain rule. So once you take the derivative of the outer functions, don't forget derivative of u, which is considered du over dx. Or derivative of g of x to the power of n. So this one can be written as n times g of x to the power of n minus 1. And then times the derivative of g of x. And the exponential, the exponent derivative that you have for this one's supposed to be called the exponential derivative. Okay, so let me just fix that. Exponential derivative. So if you see that common, well, not a common base, but it's just a base a, any random number, real number, to the power of x. So the derivative of this one is always considered a to the power of x times natural log of a. Well, there's a proof for that. So we can say that y equals a to the power of x. Okay, so if we take the natural log on both sides, so what happens if we take the natural log on both sides? You can always bring down the power. And then taking the derivative of this one, taking the derivative of the left-hand side, well, this one would be considered y over 1 over y times y prime. And then derivative of this one would be just like what? Natural log of a, because that's the real number. And then solve for y prime, we do have y prime equals natural log of a times y. Again, what's y again? So y, which is considered a to the power of x. So we just proved the formula. Y prime equals a to the power of x times natural log of a. Or the other way around. You just swap the terms. Okay, so now let's see what else. And applying the derivative, find the derivative of the function using the chain rule. So one thing that you want to do, you want to set up the inner functions. So the inner function, I would like to use that as u. So x to the power of 4 plus 3x squared minus 2. Again, for those you might be wondering what u is, called the inner function. So that means for u prime, then that would be considered 4x to the power of 3 plus 6x using the power rule. And now from here, just rewrite it so it's f of x equals u to the power of 5. And using that, the alternate formula for the chain rule, we do have f prime of x. So that equals 5 u to the power of 4 times u prime. And then once we set up u prime, so we just want to rewrite it, unpack, unsubstitute everything. So that means f prime of x. So that's considered 5 times x to the power of 4 plus 3x squared minus 2 to the power of 4, and then times u prime times 4x to the power of 3 plus 6x. So using the chain rule, so derivative of the outer functions times the derivative of the inner function. So what happens if I don't want to do it this way? So if you don't want to do it this way, you need to recognize, you need to be familiar with the structure. Okay, so like the next one here, so we do have cube root of 1 plus tangent of t. Okay, so cube root plus 1 over tangent of t. So let's just rewrite it. So this one is f of t. So that equals 1 plus tangent of t to the power of 1/3. So we do know that the outer function is the quantity to the power of 1/3. So started off with the outer function derivative. So bring down the power. And then 1 plus tangent of t. We don't change that because that's just the quantity. To the power, using the power rule. So 1/3 minus 1. So it's negative 2/3. And a lot of people thought that this one is done. But the thing is that inner function, don't forget, it's 1 plus tangent of t. So we need to find the derivative of the inner function here, which is what? derivative of 1, 0, derivative of tangent of t, which is secant square of t. So multiply everything by secant square of t. And now what about this one here? This one is quite similar. So I believe this one is x e to the power of ax. Okay, let me just rewrite it. So this one using the product rule formula. So we do have y prime equals derivative of x, which is 1 times e to the power of ax. And then plus derivative of e to the power of ax. We don't know what that is yet. So let's just put in this way. Put in parentheses and then put in derivative. Okay, so e to the power of ax derivative, the little apostrophe, and then times x. So now let's find out the derivative of e to the power of ax. Well, this one is basically just what? E to the power of ax. But don't forget, inner function is what? A. So we need to multiply that by a. X, we just carry that over. So eventually this one is e to the power of ax plus ax e to the power of ax. And what about for d? Again, if you recognize the structure, so it's about the product rule, but also don't forget about the chain rule. So started off with that f of x, which is this whole thing right here, x squared plus 1 to the power of 3. Bring down the power, so 3 times the quantity, x squared plus 1 to the power of 2. And then don't forget, anytime that you take the derivative of the whole functions, you need to take the derivative of the inner function as well, which is considered 2x. And then times cotangent of nx. Again, we're using the product rule. And then plus the derivative of cotangent of nx, which is negative cosecant square of nx, because that derivative of cotangent is negative cosecant square of the quantity. And then don't forget that nx is the inner function, so times the derivative of nx, which is what? N. And then times the original function here, f of x, which is what? X squared plus 1 quantity to the power of 3. And for the rest of this, you can just simplify it. So which is what? 6x times the quantity of x squared plus 1 square times cotangent of nx. And then plus, so this one, or just say that minus n cosecant square of nx. So I just bring up the n to the front, and then times x squared plus 1 quantity to the power of 3. Okay, so that one is a little bit complicated. Okay, so now let's see what else. And what about this type of structure? So again, derivative of the outer functions. So basically just carry down the same thing here. Because that e to the power of the quantity, it's just the same thing. E to the power of the quantity. But don't forget about the inner function. Derivative of x sine of x using the product rule. So times 1 times sine of x plus derivative of sine of x cosine of x times x. Okay, so that would be the derivative. And then this one is just like a to the power of x. So y prime, it's just considered natural log of 2 times a, which is what? 2 to the power of cosine of pi over x. But don't forget, the power, that's considered the inner function here. So times derivative of cosine of pi x, derivative of cosine is negative sine. And also there's another inner function, which is what? Pi x. So derivative of pi x times pi. So always goes from outside and then inside and then another inside function. So what about for this one, f prime of t? So this one is just considered derivative of tangent, which is what? Secant square, the quantity, e to the power of t, times the derivative of the inner function, e to the power of t, which is what? E to the power of t. And then plus derivative of e to the quantity. Well, e to the power of the quantity, then that's just the same thing, e to the power of the quantity tangent of t. But don't forget, tangent of t, that's the inner function for e to the power. So derivative of tangent of t, then that'd be secant square of t. And then this one is kind of tricky, so this one, let's just rewrite it. So we do have y equals sine of the quantity, cosine of tangent of pi x. But for cosine, we do have a radical here, so that's what? To the power of 1/2. Okay, so if you deal with things like this, inner function, there's so many inner function involved. Again, always from outside to inside. So derivative of sine, then that would be considered what? Cosine. The quantity. Okay. And then what else? The next one would be the power. So power, you can bring it down 1/2 to the quantity of -1/2. Okay, so one thing at a time. And then after that, so that would be what? Cosine, derivative of cosine, then that would be negative sine. So it's all multiplying. So negative sine of the quantity. And then derivative of tangent, then that would be what? Secant square of the quantity. And then finally, we get into the most inner function, which is what? Pi x, derivative of pi x, which is what? Times pi. And now, what about the rest of the parentheses, the quantity here? We just want to go back from inside to outside. So this one is secant square of what? Pi x. And then this one is what? Sine of, because that's derivative of cosine. Then that'll be what? The next inner function. Going back to outside, so tangent of pi x. And then 1/2 of the quantity, cosine of tangent of pi x. Okay? And then the rest of this, cosine of this whole quantity, cosine of to the power 1/2 tangent of pi x. It's always from, well, the time that you take the derivative, the process, the procedure, it's all about from outside to inside. But once you rewrite it with the quantity, it's always from inside to outside. So find an equation of a tangent line to the curve. So this one, using the graphing calculator, well, we can use the graphing calculator, but what happens if we do it without a calculator? So find a derivative, so y prime. So derivative of this, well, this one derivative of 3, then that'd be what? 0 times the quantity of 1 minus e to the power of negative x, using the quotient rule. And then derivative of 1 minus e to the power of negative x, then that will be considered 0 minus e to the power of negative x times -1, because that's the power rule with the chain rule. And then all over 1 minus e to the power of negative x quantity squared. So simplify the whole thing. This one turns out to be 0. Cancel it out. Minus 0 minus e, negative, 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 so still negative. So negative e to the power of negative x. All over 1 minus e to the power of negative x quantity squared. Again, this one is just y prime, so plug in 0. So plug in 0 here, so we got y prime of 0, which is e to the power of 0, then that's 1, but don't forget it's -1. There's a negative sign right in front of it. E to the power of 0. So this one also, it's what? 1. But 1 minus 1, what do you notice? It's 0. Now what happens if the slope is undefined? If the slope is undefined, that means we only have a line of the equation as what? X equals 0. It's a vertical line. This one you can say that's a vertical tangent. So that's why the line is always what? X equals 0. It's a vertical straight line. So for the next one, find all points on the graph of the functions f of x equals 2 cosine of x plus cosine square of x, at which the tangent line is horizontal. Again, keyword tangent line is horizontal. What does that imply? The slope is 0. The instantaneous rate of change is 0. So find that f prime of x. So we do have -2 sine x and then plus 2 cosine x using the chain rule for this one. Power rule first, bring down the power. And then derivative of inner function, cosine, derivative of cosine, which is what? Negative sine again. So what we got here, set equal to 0. So it's -2 sine x minus 2 sine x cosine x. Set that equal to 0. So now let me open up the new slide here so I can just solve for x. Okay, let's just go back. So negative 2 sine x minus 2 sine x cosine x. Again, we want to find out the what? The points. All points, okay? So that means we need to find out the x, y value. So let's just solve for x first. Once we solve for x, we can just plug in the number back to the original equation and solve for y. And let me take a look at that, the original function here. 2 cosine x, cosine square of x. Okay, so solve for x using all the trick knowledge, things that you learn. Okay, so what we got, take out the greatest common factor, negative 2 sine x. So we got 1 plus cosine of x, because we took out the negative. So solve for x here, so set that 2 sine x equals 0, negative 2 sine x equals 0. And also set that 1 plus cosine of x equals 0. So that means sine of x equals 0. Back to the unit circle. If sine of x equals 0, so that means it's right at the position of what? 0 radian. And also what? 180 degree or pi. Okay, so x would be 0 radian and then pi. And now what about if 1 plus cosine of x equals 0? So that means cosine of x equals negative 1. So that means x is what? Pi. Because that at this position is negative 1 comma 0. So plugging a number back here, so started with y equals y of 0. So 2 cosine of 0 plus cosine square of 0. So cosine of 0 is 1, so 2 times 1, that's 2. Cosine of 0 is 1. 1 squared, that's 1. So which is 3. So we got 0 comma 3. And what about a pi? So plug in pi back to the original equation. So 2 cosine of pi plus cosine of pi, quantity square. Got to be careful, it's cosine of pi, quantity square. So cosine of pi is negative 1. Negative 1 times 2, negative 2. Cosine of pi, negative 1. Negative 1 square, 1. So it's negative 1. So we got pi, comma, negative 1. So those are the points for the solution. Okay, so now let's see what else. 3.4, going back. Again, finding all the points. So find the 40th derivative of y equals sine of 2x. So this one, again, inner function is what? 2x. But it's the 40th derivative. Do we need to go all the way from the first to the 40th derivative? Well, the thing is that we just want to find out the pattern here. Once we can figure out the pattern, we can figure out the derivative, the 40th derivative. So the first derivative, y prime, then that would be considered cosine of 2x times 2. Again, using the chain rule. So y double prime, derivative from here. So then that would be negative sine of 2x, because derivative of cosine is negative sine, of the same quantity. And then times, well, the 2, it's a coefficient. We need to carry that over. And then don't forget, derivative of the inner functions, another 2 right here. So then that would be 2 square. Then y triple prime, the third derivative, derivative of negative sine of 2x. Then that would be considered negative cosine of 2x. Okay, so negative cosine of 2x. And now what else do we know? And take the derivative of 2x, then that would be another 2. So 2 times 2 squared, then that would be 2 to the third power. And now going to the fourth derivative, then this one will be considered what? Sine of 2x. Because that derivative of cosine of 2x is negative. It's a negative sine of 2x. So negative, negative. So that turns out to be positive. And then times another 2. So 2 to the power of 4. And now what about for the fifth derivative? Then that would be going back to what? Cosine of 2x times 2 to the power of 5. Now, do you guys see the pattern here? So first derivative, that's cosine. Second, that's sine. And then the third one is going back to cosine. So it's just like going back and forth, alternating. And then the sign change. So every fourth derivative, it's always going to what? Sine. So this one is the 40th derivative. So that means for the 40th derivative, that would be considered what? Sine of 2x, once again. But it's to the what? 2 to the, what's the power? The 40th degree. So that one is just showing the pattern here. There's no need to evaluate 2 to the power 40. That would be kind of crazy and tedious. So use the chain rule to show that derivative of d over d theta, sine of theta, equals pi over 180 cosine of theta. So imagine that theta, it's the inner function here. So I put in the parentheses, okay? So we want to show that the left-hand side is the same as the right-hand side. So now let's start out with this. So d over d theta of sine of theta. So one thing that we notice, so derivative of sine theta is always what? Cosine of theta. But don't forget, you multiply by the derivative of the inner function, theta. So what's the derivative of theta? So then that would be what? 1. Now the thing is that if that's considered 1 degree, we can always convert that degree to radian. How do you convert that 1 degree to radian? Simply multiply that by pi over 180. Because that everything got to be in radian. And theta right now, it's in degree. So convert that to degree. From degree to radian. So we do have cosine of theta times 1 times pi over 180. Which is considered cosine of theta times pi over 180. And that's the formula we do. We just show that right here. Okay, so now let's see what else that we have for this. That's it. So for the chain rule. Alright, so thank you for watching the video today. So I'll see you guys next time. You guys take care.